Hello, this is Kevin Olson from TextLearn.com and welcome to Lesson 5.2 of the Intro to Java series. In this lesson, we are going to be discussing algorithms with arrays. So now that you know how to create arrays, it's time to learn how to perform useful operations with them. In this section, we will create a few simple algorithms with arrays, and this will introduce you to the basic concepts of algorithm development and strengthen your knowledge of array usage. So the first example I would like to go over is finding the max. So what we're going to do is we're going to have an array of integers, and we just want to loop through this array and determine what the maximum value is. So in order to do this, let's say we have an int array, and we're going to give this the values 5, 7, 10, 3, 4, and 0. So that'll be our int array. And what we want to do is we want to go through each index and pick out the best or the maximum value, which in this case will be 10. So in order to do that, we are going to have a loop. So we will have our main loop here. And what this loop will do is it'll go through each value in the array and check the current value against the found maximum value. So let's have an integer max equal 0. And then we will begin our loop. Our loop will check to see if the current index of the array, so if the index I is greater than the maximum, well then we will know that the new maximum is going to have to equal that indexed value at I. And that's just kind of shorthand writing there, so don't pay much attention to that. So we go through each one, it determines the maximum, and if the number is higher than the next one, or than the current found maximum, we know that that must be our new maximum. So the first time it goes through, it'll see 5. It'll say, okay, 0 is less than 5, or 5 is greater than 0. And then we will know that the new maximum will have to be 5. So 0, it's at 0. 1, I should have wrote max up here. So 0. And we'll have the index I. So when we go to 0, the max will be 5. And then once we go through again, we'll see that it's a 7. 7 is greater than 5, so our new maximum value is going to be 7. It's going to go to 10 next. So once we hit 2, the maximum value is 10. Then it'll check the third index, and it'll see that 10 is greater than 3, so it's going to leave the maximum at 10 because the check here failed. It'll go to 4, and it'll say 10 is greater than 4, we'll leave it at 10, and then finally it'll hit 0, and it'll say that 10 is greater than 0, and it'll leave the maximum being 10, and then by the time the loop ends, we will have our maximum value being 10. So let's go into Eclipse and try that out. First things first, we will create an int array, int myArray equals, and we'll give it some random values. Okay, so that is my array of integers, and I need to end that with a semicolon. Now we have our integer max, which we're going to just set for 0 for now. And then we have to loop through each index in the array. So do for in I, or I is less than my array.length. And then we'll do I plus plus. So we'll increment through each of the values in the array. And I forgot to assign 0 to I, so for integer I equals 0, I is less than my array.length, I plus plus. Alright, now all I have to do is check to see if the current index, so if my array, the current index, is less than the known maximum, or greater than the known maximum, I should say, we will go ahead and set the new maximum equal to this value. Okay, so that should work. Then we will just print out system out print line. The maximum is plus max. So we're just going to print out the maximum. Let's run that. The maximum is 5,353. So that is correct. It successfully looped through each of those, checked them all against each other, and now we know that the maximum value must be 5,353. Okay, and the next example that we have is sorting an array. So what this algorithm is going to do is it is going to loop through all the indices in an array, and it's going to end up putting them in order from smallest value to greatest. So all we want to do is take an array, go ahead and move everything over, sort it until we have the same array, but it's going to go from less to greatest instead of just random values like it is right now in that example down there. Alright, so how is this going to work? Well, first we're going to have an int array, and I'm just going to quickly write out some random values here. So int array is going to be equal to, let's say, 5, 6, 7, 10, 2, 1. Okay? And we're going to want to sort that from left to right. In order to do this, we're going to have an outer loop and an inner loop. The outer loop is going to go through each index, and every time it runs, it's going to end up moving the greatest element towards the end. Moves greatest towards end. Then we will have the inner loop, and this will be our worker loop, let's call it. And this is going to be the loop that actually does the swapping. So it'll swap 5 and 6 if 5 was greater than 6, 6 and 7 if 6 was greater than 7. So the inner loop will be checking the current index value. So it checks the current value against the next, against next value, and it will swap them. And swap if this current value is greater than the next. Okay, so the first time this runs through the outer loop, it's going to go to the inner loop, and the inner loop is going to see 5 and 6. It's going to say, well, okay, 5 is less than 6, so I'm going to leave that one alone. It's going to see 6 and 7. It's going to be like, oh, okay, 6 is less than 7. That looks good. It's going to go on to the next one. 7 is less than 10. It's going to leave that alone. And then once it gets to that 10, it's going to say, okay, 10 is greater than 2. So I need to swap these guys. So now 2 is going to be over here, and 10 is going to be over here. So it swaps those. And then it checks 10, which is now over here, against that 1. And it knows that the 1 is going to be less than 10, so it moves 10 to the end. 1 is now located here, 2 is now located here, and 7, 6, and 5 stayed the same. So now it moved 10 all the way over to the right, just like we would want it to. Then it'll loop through again the outer loop. The outer loop will call the inner loop. The inner loop will now be checking against this guy in red here. So let's go to the next one. And let me just kind of delete some of this to make more space. Alright, so it's going to see 5 and 6. It's going to leave those alone because we know that the 5 is less than the 6. It checks 6 against 7. Well, it's going to leave that alone too. Then it's going to see that 7 is less than 2, or 7 is greater than 2, so it's going to swap those two values. So now the 2 is going to be here. The 7 is going to be here. It's going to check that 7 against a 1. It's going to say, well, okay, that 7 is greater than 1, so it's going to swap those. The 1 is now going to be here. The 7 is going to be here. And then finally, it'll check 7 against 10. It'll know that 7 is less than 10, so it will leave that alone. And now we have 7 moved over towards the end. Do it a third time, and now we have 5 against 6, so that stays the same. 6 against 2 now, so it's going to actually move the 2 over 1. It's going to have 6 being here. It's going to check 6 against 1. 1's going to move. 6 is going to be here. And then we will check 6 against 7. 6 is less than 7, so it'll leave those alone. 7's still less than 10, so it will leave that alone. So now we have 6 moved over to the right. And as you can see, each time we get a new value that is the next highest number falling into the proper place. So by the time our inner loops and our outer loop goes through each one, we will have a value of 1, 2, 5, 6, 7, 10. All right, so let's go ahead and try this out in Eclipse. So I can just leave my array the same way it was before. What I will need to do now is modify the actual loop part. So I'll just leave the sample array like it was. So for integer I is equal to 0, I is less than my array dot length, and we increment I by 1 each time. So that is our outer loop, and now we have to have our inner loop. For integer x equals 0, x is less than my array dot length, and x plus plus. So now we have an inner loop and an outer loop. So if you multiply that together, this array will end up running the array.length squared amount of times total. That's how long it will, how many steps will be involved in finding this out. So now we're going to have an integer, temp storage, equals my array x plus 1. And we have to have this temporary value in here because when we swap the values, we can't just overwrite the next value. We have to have something that is keeping track of what that value was before we go ahead and overwrite it. Otherwise, we won't know what that original value was and we won't be able to put it back into the last value. So we're going to have integer temp storage equals my array plus 1. And then we'll have my array x plus 1, or actually I should do the if statement first. If my array x is greater than my array x plus 1. So this is actually the condition that's checking to see if the current element is greater than the next element, and then we're going to go ahead and swap them. So this is where we need the temp storage value. So once we have that, we can do my array x plus 1 is equal to my array x. So now we have taken the next value and we've set it to the current value. And then we can go ahead and set the current value, my array x, equal to that temporary storage. Because of course, if we were to just do my array x equals my array x plus 1 at this point, it would give us the same exact value and it would set both values being equal to my array x, which is not what we want. We want them to be swapped, not all set to the same. So that's going through and it's swapping everything out for us. And that's really all there is to this algorithm. It's a little more complicated than the last one, but still overall very simple if you understand that concept. Now we can just go through each element in the array. So for each int, let's call this z in my array, for each loop there. Then we can just do system out print, and we'll print out a comma, and we'll print out the value of z. So that'll go through our array, print out all the values. We run that, and I have an exception in thread main, index out of bounds. So what did I do wrong here? My array length minus 1, that is what I needed to put in here. I iterated too much there. Right. Because, not there. Because I have it going from the beginning to the end, at the end now it's saying it's checking 34 against the next index, which does not exist. So we have to have this be minus 1 here, because we can't check 34 against nothing, we would have to check that against, it'll already be checked against the previous one. So the last index does not get checked against a next value, and that's why we have that index out of bound exception occurring. So I have to put that -1 in there. All right, and I run the program now and it works successfully. You can see it ordered all those numbers in order from least to greatest, 0, 23, 23, 24, 34, all the way up through 5,353. So it was able to sort our array and put them all in the proper positions. And now that we've done that the hard way, last thing I want to discuss in this section is the arrays sort method. And the array sort method will basically do what we just did with these two for loops for us. So we don't have to do that anymore. We will go ahead and check out this example here. All we have to do is call arrays.sort. Then we pass the array as a parameter, and it'll automatically sort them in order from least to greatest for us. So we can do arrays.sort, and there are different sort functions that sort the arrays differently, but for now we will just use the default sort method, and that'll go from least to greatest. We run that, and again it has sorted our values from least to greatest. Okay, so that is the end of this lesson. The last exercise that I have here is 5.2c, array calc. Directions: create a calculator which takes an array of integers, calculates the minimum value, the maximum value, the median value, which is the middle, and then it will also calculate the average of all the values in that array. And I will have the solution posted for that online shortly. Thanks for watching.